Hello everyone and welcome to another Maths tutorial video. Now I'll be discussing Form 5 Additional Mathematics Chapter 8 Probability Distribution Long Question Example 1 Part 1 video. Okay, before that please hit the like button to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Alright, let's jump to the video now. Okay, you might be wondering why you are not seeing any example 1 question over here. Okay, the reason is for this video, I'm preparing the overall notes for the probability distribution, specifically on the binomial distribution. Okay, the reason is I personally find out that for this chapter, it's easy for you to do the exercise once you have understand the knowledge. But for those of you who have no idea what the binomial distribution and the normal distribution means, it's difficult for me to just straightforward do the question. So I feel it's better for me to write down the notes and give you some early idea on how the binomial distribution and the normal distribution notes, and then on how to solve this type of problem. So at least it will be easier for you to encounter the question. Okay, for the normal distribution you will have a look at the future. For now we'll take a look at the binomial distribution. Okay, before I forgot, within probability distribution you have two subtopics here guys. For the first one is binomial distributions and another one is the normal distribution. Okay, let's take a look at the binomial distributions now. Okay, what it means by binomial distributions? It means possible outcome based on repetition on success and failure. Okay, by the way, bi means two over here guys. These two is obeyed the definition over here, which is success and failure, the repetition of success and failure. Okay, the definitions are pretty similar to probability, however they do have their differences. Okay, so to differentiate between a probability and binomial distribution, okay, I'm going to show you the very simple example. Okay, let me pull this paper up. Okay, so for probability, which you have learned in the previous chapter, okay, let's say for example you toss a coin once. So the probability of getting the heads is very straightforward, is 1 over 2, and the probability of getting tails is 1 over 2 as well. Okay, by the way, when you toss a coin you have two faces over here. The first is the head. When you toss you will have a head or tails. So the probability of getting heads and tails is respectively 1 over 2 and 1 over 2. Okay, this concept is pretty easy. However, imagine that you are going to toss a coin 10 times and then you want to find the probability that you obtain exactly 5 heads. Okay, so how this possible? So this is considered a repetition guys. So you are finding your probability that you're obtaining 5 heads. So these heads is considered your success. So your question emphasizing you to find heads instead of tails. So you're trying for 10 times and you want to check whether you get 5 heads or not. Okay, in reality, when you toss your coin 10 times, you might not be getting exactly 5 heads and 5 tails. You might be getting 3 heads and 7 tails, or you might even get 0 heads and 10 tails. So it depends on the real life situation. So this binomial distribution is just a calculation on how much your chances for you to get this particular distribution over here guys. So since this distribution is 5 heads and 5 tails, it will show you some calculation. So how to do the particular calculation? Okay, please hold on. I'm going to show this in the in the coming explanation. So please hold on for a moment. So these are the distinct difference between probability and binomial distribution. Okay, for probability you toss your coin once, and then whereas for your binomial distribution you toss a coin 10 times and then you find the probability that you've obtained 5 heads. Okay, moving on to the next note. So these are the 3 general steps for you to solve your binomial distribution. Okay, I write here in short form BD over here. Okay, the first step which you need to do is identify the probability which the question emphasizes. Okay, back to this example, toss a coin 10 times and you find the probability that you obtain 5 heads. So the question immediately emphasizing you 5 heads over here. So in this case, you should take your heads as your probability of your success. So in this step, which I'm mentioning you need to identify the probability of success. This will be your first step, okay, which is denoted as letter P over here. Okay, once you identify the probability of success, so for the next step, what you need to do, you need to find the probability of failure, which is Q. So to find Q is very simple, is equals to 1 minus the probability of success, which is P. Okay, why 1? Because your total outcome of your probability is equals to 1. So your value of probability will be in the range of 0 to 1. Okay, I hope you understand the concept of the 0 and 1. 0 is the likelihood that the event will definitely won't happen, and the 1 is the likelihood that the event will definitely happen. So the probabilities values will be always in between 0 to 1. Okay, moving on to the third step. So once you find the probability of success and failure, in this case you find the number of trials. Okay, in this case the number of trials n is 10 times. So you're tossing your coin 10 times, and you finding that how much your probability you get when you toss, you get 5 heads. So this is the basic example. So how are we going to encounter this type of question? Okay, I'm going to show you the formula now. So please hold on. So this is one of the formula, excuse me, which you're going to use in the binomial distribution, which is P in a bracket, X is equals to R, close bracket equals to NCR times with P to the power of R times with Q to the power of N minus R. Excuse me. So P stands for the probability. So X is the binomial discrete random variable. R is the number of success. N is the number of trials. P is your probability of success, which I mentioned just now, which lies your values between 0 to 1. And Q is the probability of failure, where you get your Q equals to 1 minus P. Okay. This is your additional formula which you'll be learning in the binomial distribution. To find the mean of the X binomial discrete random variable, you equals to number of trials you times with the probability of success. So this is your mean. To find your variance of X is equals to N times with P times with Q. And then to find the standard variation of X, you just square root the variance, which is square root NPQ. So this is one of the additional formula which you'll be using in the binomial distribution. Okay, these are some of the important note which I personally write over here. Okay, when you have to look at the question, you make sure you have to look at the key points over here. When the question mentioned exactly R, so you need to mention over here P in a bracket X is equals to R. Okay, if at least R means you need to equals to P in a bracket X more than equals to R. When the question tells you at most R, okay, which you have to equals to P in a bracket X less than equals to R. Okay, these three example is just one of the possible cases that you might have a look in the binomial distribution. In fact, they have many, guys. Okay, so you need to know how to use the inequality sign and the equal sign over here. Okay, back to our example over here. I'm going to show you one simple example. Toss a coin 10 times and you find the probability that you obtain 5 heads and 5 tails. Okay, what does this mean, guys? This means that you toss your coin 10 times and you wanted to get exactly 5 heads. So how much is this probability? Okay, I'm going to calculate it now. Okay, so this is just example 1. So to get exactly 5 heads, so I write here in short form H. Okay, so you need to set your probability of success, which is equals to 1 over 2. Okay, this 1 over 2 is actually for the heads. Okay, once you find your probability of success, you need to find the probability of failure, which is Q, which is equals to 1 minus 1 over 2. From here, you get your answer, 1 over 2. This is for the tails. Okay, you already got your probability of success and the failure. Now proceed to find the number of trials. Okay, in the question, the number of trials is actually 10. Okay, and the number of success which you want to find, which is in this case is 5 heads. So that means you must get 5. Okay, so in our calculation, how you need to do is, so for probability x is equals to 5. So you proceed to do the calculation. Out of the 10 trials, so you choose only 5 in a bracket. So since your probability is 1 over 2, so you can write here in decimal as well. 0.5 to the power of 5 and then 0.5 to the power of 5. So these 5 I got from here, guys, the number of success, and these 5 I got from 10 minus 5. So you get here 5. Okay, so this is the one of the cases. So you calculate over here. Okay, let me show you the calculation of how to do this. So 10 C 5, you get 252, and then you times with 0.5 to the power of 5. Okay, and then you times with 0.5 to the power of 5 again. So from here you get 0.24609. Okay, we will take our value into 4 decimal places. That means you will get our value is 0.2461. Okay, so from here you will get your answer is 0.2461. Okay, if you want to change it into percentage, very simple, you can just times by 100%. That means you'll get your answer is 24.61%. Okay, this will be your answer. If the question asks to mention you in percentage, okay, you do this, or if they didn't ask in percentage, you can just leave your answer in this way. Okay, so this is the answer. So what does this mean, guys? Okay, this means you have 24.61% chance of getting 5 heads within the 10 trials. Okay, like I said, even though your probability is 1 over 2 and 1 over 2 for the respective heads and tails, when you do it for 10 trials, to get your 5 heads is not actually 50%, guys. It's actually 24.61%. So this is the distinct difference between probability and binomial distribution. So I hope you understand the concept over here. Okay, let me turn back to your notes for your reference. So please hold on for a moment. Okay, that's all for my explanation. Thank you everyone for your support, and I'll see you in the next video.